So in this video we are going to solve this practice exercise. So the instructions have all been given here. It says we should import the data set called iris. We should also look at the structure of the data set and determine which of them we can compute confidence interval of means for. And after identifying those variables, we should compute those confidence intervals and should save and submit the R script. Okay. So I'll go ahead and open R and create a new R script. Okay. So to do that, I can create one here. So I have a new R script. Then we are going to go through all the steps, okay, one by one. So the first thing is to import a data set named iris. Okay. So to do that, I'll need a package called datasets. Datasets because the iris dataset is one of the inbuilt datasets. Okay. So we need the package called datasets to actually import it. Okay. So to do that, I'll actually search here and see if I have that package. So clearly I have it here. Okay. So I can come here and import my dataset. Okay. So importing dataset. So to do that, I'll need the function data, then bracket open. Then I start typing the name of the data set I want. Clearly, after stating the data here, you can see all the inbuilt data sets here. That is the one for or the one under the data sets package. Okay. So I can just type iris. Then I'll see two of them here. I actually want this one. I just click on it and run. After running, I can clearly see it here. So it means I have been able to successfully import the dataset. Okay. Now, if I want to look at the structure of the dataset, I can use the function called str, short form of structure. Then I write in the name of the dataset. Okay, then I run. Clearly, I can see five different variables here. Okay, each of them having 150 observations. Okay, and amongst all the five variables, we have four of them being numeric. So it means for these four, we can compute mean. But with the last one being categorical, okay, we can see three levels here, which is Setusa, vertical, and one other level. Okay, it means for the last one we can only compute confidence interval for proportions. Okay, we can't compute confidence interval for means. So it means we can only compute the interval for just these four. Okay, which is sepal length and width, petal length and width. Okay, so since the sepal length is, the name sounds very long to me, I might want to change the name of those variables. Okay, so to do that, I can just choose a new name. So for instance, if I'm choosing SL as my sepal length, okay, so equal to, I write the name of my data set. Okay, then I bring the dollar sign to allow me choose the variable I want. In this case, we want sepal length. Okay, then we can run that. Then immediately we see a new vector named SL. If I actually look at the values in SL, I'll get I'll be seeing this, all the values, all these values are for sepal length. So we can cross check. I'm seeing 5.1, 5.9, 4.7. If I come here, 5.1, 4.9, 4.7. See, so I'm getting those same values. Okay, let me clear this. If I want to do same for the sepal width, maybe I'm choosing SW. You can use any name you want. Okay, so iris, I choose the name of the dollars. I use the dollar sign to choose the name. I choose my width, then I run. Then I run. I see here. So we will do that for all the other four variables. Okay. So now after doing them, if I want to compute the interval for sepal length alone, I can use the t-test function as we've already discussed. Okay, so t-test, I choose the variable I want, which is SL. Then I choose the confidence interval or the confidence level. Okay, so supposing we are using 95% confidence level, we write 0.95. If you don't specify the confidence level by default, you would use 95%. Okay, so after specifying this, immediately I run this, I am going to get the results for a one sample t-test. I'm going to get a results for a one sample t-test. Now the one sample t-test has other information we might not be interested in. Okay, so if I want to see just the confidence interval, the same way we use the dollar sign to choose variables, I can bring a dollar sign here and write conf.int, short form of confidence interval. Okay, so this will just give me the results for just the confidence interval. If we look at the value here, we can clearly see it is the same as what I have here, but this is mixed with the results for the one sample t-test. Okay, so if I want to see just that of the confidence interval, I can add this continuing code, then I'll be able to see the results for only the 95% confidence level. Again, I might decide to assign this whole code to a particular name, say maybe conf underscore SL. Okay, so meaning I am creating a confidence interval for the variable SL. Okay, so if I run this, okay, then it means I have created a variable called conf.sl. Okay, so if I want to see the results of all this analysis, I can just write conf underscore sl and run, and I'm going to still get the same thing. So whichever approach you choose, you are going to get the same answer. Okay, if you want to do the same thing for the other variables, it's the same. Supposing you don't choose a variable name for them, maybe you will still want to write this whole lengthy code. This is how to go about it as well. It's just t-test. Okay, in this instance, maybe I've not decided on a variable name for maybe petal length. Okay, so to choose that particular variable, we are just going to go by the same approach, which is iris underscore dollar sign petal width. Okay, then I would add my confidence level. In this instance, let's use 0.90 for 90%. And if I want the confidence interval for that, I just add this and run, and I'm getting my results. Okay, if I add a different variable to this, okay, since this is a t-test, okay, we have several types of t-test. Okay, we have the one sample, we have the paired sample, we have the independent sample. For the paired and the independent sample, we can choose two different variables, but then if we choose the two different variables, it will not allow us to see the confidence interval for each. This is what I mean. Supposing I add another one, which is maybe SL, to the code. Okay, then I run this. Okay, and I run this. You see the results I'm getting here? I'm only seeing one confidence interval, but then I want the confidence interval of both. So it means if you want a confidence interval for just one variable, okay, or two variables, you have to do it separately. You can't do them or all the two at the same time. Okay, so I'd have to clean this out. Then I have this, and I can clearly see this. Okay, and I hope this helps.